In the next few minutes, we will discuss a cognitive framework for active learning. But first, let's define what we mean by cognition. This is anything that is going on in people's heads, such as attention span, perception, decision-making, learning, and problem-solving. For us, specifically, we're interested in the thought processes involved during the learning cycle. We know that learning is an evolving process where students must adapt to new situations as they encounter new knowledge. Learners are active constructors of knowledge, not passive recipients. The research on the relationship between instructional methods and student learning has been a focus within STEM education for decades. Many studies show that active learning methods are more effective than traditional lectures in helping students understand complex topics, as you saw in the paper that you read recently by Scott Freeman and colleagues. However, there have been some studies that show no difference with active learning methods, or in fact, an opposite effect of an active learning approach to teaching. What this is showing us is that approaching assessment of teaching methods and learning outcomes is really challenging. Discrepancies in the results can be explained by the variability in the scope of how researchers are defining active learning methods. So using a broad definition of active learning can obscure the specific cognitive processes associated with each type of activity. Therefore, applying a framework within which we can classify teaching techniques will help us to improve our assessment by allowing comparison across teaching methods. A framework can also help us improve instruction, which may ultimately improve student learning. The theory that we will use to frame our discussion is that as students become more engaged with the material, their learning will increase. The framework that we will use is called the Differentiated Overt Learning Activities Framework, defined by Micheline Chi in 2009. And it divides active learning methods into modes depending on students' cognitive engagement. The lowest level mode is the passive method. And this is exactly what you would think of when you hear the word passive. It's modeled in the traditional lecture where students simply sit and are the recipients of information. Active methods involve learners in hands-on manipulation of the materials. Now I want to take a step back here and point out that the title of this module is in fact active learning. And that is a very broad term that we are using to contain all of these various modes. The next step up from active methods are constructive activities, where students are expected to facilitate the generation of new ideas beyond those directly presented. Moving forward, interactive activities generate ideas that build on each other, where all students are contributing substantial intellectual effort in collaborative settings. Now let's take a look at a paper that really sums all of this up and applies some concrete details to this theory. So this table is presenting the characteristics, overt activities, and cognitive processes for the three modes that we just described. We've already defined the characteristics, so let's focus on the overt activities. So take a minute here to read through the list and see if it reminds you of another framework that you are very familiar with. So you'll likely noticed that the terms within this table mapped quite well onto Bloom's taxonomy. So as students are moving from active to constructive to interactive modes, they are engaging with the material in a more meaningful way. As we move through the remainder of the module, always think back to this framework and see how our specific techniques, again, map onto this cognitive framework. When students engage in dialogue and construct knowledge collaboratively, they not only generate knowledge on their own, but they further benefit from their peers' feedback and contributions. And lastly, by manipulating the learning materials, students activate relevant existing knowledge and assimilate new information to fill in their knowledge gaps.